Okay, today we're going to factorize a polynomial over the real, complex, and rational field. Now, I stuffed this up in another video. I did everything correct except in the end. I mixed up the real and the rational cases, so I have to do this again. Okay, so if 1 plus I is a zero of this polynomial whose coefficients are all real, then 1 minus I, according to the conjugate root theorem, is also a zero, according to the conjugate root theorem. And so if you were to do the roots and coefficients method, you will let the other two zeros be alpha and theta. I don't like writing beta. Minus, plus, toggling. That's one special. So if you add all the roots together, and the formula is minus b on a, hence my toggling here. And b here is minus 2, so it's minus 2 on 1, so the answer is 2. So that means that 2 plus alpha plus theta is 2. That means alpha plus theta is 0. That's equation 1. You then multiply the product of the roots together. The nice thing about the complex number and its conjugate is that when you multiply together, you get a real number. That's a real number. And the formula here is the product of the roots is minus 6 on 1, which is minus 6. So you have a second equation, which is alpha theta equals minus 3. And it's just a matter of solving them two simultaneously. You don't have to solve it. You just sub it in, and you get alpha minus alpha equals minus 3. So alpha squared equals 3. So that means then when you solve that, it's plus or minus root 3. So when alpha equals root 3, theta equals minus root 3. And when alpha equals minus root 3, theta equals root 3 when you sub it back. So that means that these are your roots. All your roots are 1 plus I, 1 minus I, plus or minus root 3. So if you were to factorize pz over the complex first, it'll be z minus 1 minus I, z minus 1 plus I, z minus root 3, z plus root 3. So that's over the complex. I gotta be careful because I stuffed this up last time. And then if you were to put it over the real, then you collapse this out to make it real. And that's your answer. And there's a fast way of expanding this, which is another video. But when you expand that, you get this. So that's over the real. And then over the complex, over the rational rather, I need to start up again. Then you get this. Because root 3 is not rational. And that's what you get. You combine this, so that's your rational field. That's where I stuffed up last time. I called the real rational real. So, and that's where I stopped.